In this video, we're going to prove the formula for the distance from a point to a line in R3. So just look at the diagram that we have here. We have here a line shown in red with the vector equation R equals R naught plus SM. That line has the direction vector M. On the line is point Q, and off the line is point P, and that's the point whose distance we're trying to determine, the perpendicular distance of that point to the line. Okay? Well, just looking very simply regarding this right-angled triangle that we have here, the right-angled triangle PQR, we can see that sine theta is obviously going to be equal to the opposite over the hypotenuse. In other words, sine theta will be equal to the distance that we're looking for over the magnitude of the vector QP. Okay? So multiplying both sides of this equation by the magnitude of the vector QP, we get that the distance we're looking for is equal to the magnitude of QP times the sine of theta. So we're just going to remember this right here. We're going to file it away. That's equation 1. Now let's begin another view of this situation. Remember that, and we'll bring it all back full circle. Remember from an earlier video that we said the magnitude of A cross B will equal the magnitude of A times the magnitude of B times the sine of theta. By extension, the magnitude of M crossed with QP will be the magnitude of M times the magnitude of QP times the sine of theta. Okay? So let's take equation 1 and equation 2 and let's highlight them on the next slide. Okay? And now let's just do a pretty simple analysis. Let's just take this equation 1 that we have right here and sub it in so that instead of saying magnitude of QP sine theta on equation 2, instead of that, we call it the magnitude of M times D, because we literally said D is this magnitude of QP times sine theta. So the magnitude of M crossed with QP is going to equal the magnitude of M times D. And that's what we've written here. Or in other words, the distance that we're looking for will equal the magnitude of M cross QP over the magnitude of M. And we've proven the formula that we set out to prove.